Today's topic is writing linear equations and their graphs. When given a linear equation such as y equals x plus 2, the graph of that equation represents all of the points that make that equation true when substituted into the equation. Since there are infinitely many points that can be substituted into the equation to make it true, we put arrows on the end of our graph. To write the equation of a line that has a slope of -2 and passes through the point -3, 7, we will first plot our point -3, 7. This point will be our starting place, and we will use the slope to help us plot more points on our line. The slope of our line is -2, or -2 over 1. From the given point, this tells us to move 2 units down and 1 unit to the right to plot the next point. We should continue this pattern from point to point until we have reached the edges of our grid. To determine the equation of any line, we will need to know two things: the slope, which we know is -2, and the y-intercept, or where the line crosses the y-axis. It is clear to see that when we draw our line, the line crosses the y-axis at +1. Therefore, the equation of the line with the slope of -2 and passing through the point -3, 7 will be y equals -2x plus 1. To write the equation of a line that passes through the points 2, 8 and -4, -1, we will first plot our 2 points. Since we are not given the slope of our line, we will need to find the slope between the 2 points. To do this, we will look at the point furthest to the left. Slope from one point to the next is calculated as rise over run. From -4, -1 to 2, 8, we will rise 9 units and we will run 6 units. As a result, our slope is 9 over 6, or in simplest terms, 3 over 2. Using this slope, we can plot more points on our grid. We may choose to start at -4, -1 and move up 3 units and right 2 units to plot the next points. Continuing this process to the edges of our grid will yield enough points to graph our line. In this case, our y-intercept is +5. And again, with our slope being 3 over 2, the equation of our line passing through 2, 8 and -4, -1 is y equals 3/2 x plus 5. When given the opportunity to graph, we have been writing the equation of our lines in slope-intercept form, or y equals mx plus b, with the m being the slope and the b representing the y-intercept. Another format used to write the equation of a line is point-slope form. The slope is still substituted in for m, while any point on the line is substituted in for x1 and y1. Often we will use this format when determining the equation of a line without the use of a graph. To calculate slope without a graph, we can substitute any 2 points on the line into our slope formula, where slope, or m, equals the change in y, or y2 minus y1, over the change in x, or x2 minus x1. To write the equation of a line that passes through the points -3, 7 and 3, 3, we must first calculate the slope between those 2 points. To do this, we label our points x1, y1 and x2, y2, and substitute into our slope formula. M equals the change in y, or y2 minus y1, over the change in x, or x2 minus x1. After we substitute 3 minus 7 over 3 minus -3 and subtract, we end up with -4 over 6, or -2/3. After I find my slope, I'm ready to find my equation. To do this, I use my slope and one of the 2 points and substitute those values into my point-slope form of the equation. Y minus y1 equals m times x minus x1. For the y1 and the x1, I will put in the coordinates from my point. For the m, I will put my calculated slope. y minus 7 equals negative 2/3 times x minus negative 3. To simplify that just a little bit further, y minus 7 equals negative 2 over 3 times x minus a negative 3 is just really x plus 3. Here I have written the equation of a line that passes through the points negative 3, 7 and 3, 3 in point-slope form. If I want to convert this equation into slope-intercept form, I simply need to solve for y. To do this, I will use my distributive property. Y minus 7 equals negative 2/3 x minus 2. My final step will be to add 7 to both sides of my equation. I get y equals negative 2/3 x plus 5. I now have the equation of the line in both point-slope form and slope-intercept form.